Well, all right. So we're going to probably take a bit of a windy road to kind of get to the title of the presentation, Data for AI. That's not the title we had in the agenda, but that one was way too long and was developed from our marketing people. Really what we're going to talk about is data for AI and an interesting way of getting there. All right. So if you're not familiar with Cohesity, we were founded in, I think, 2013, 2012, right? So we're just a little over a decade old. And we were formed, actually, let me take a step back. Our founder, the gentleman who founded the company, he had done a couple of interesting things in his life before he got to doing Cohesity. The first thing that he did was he was, I think, employee in the hundreds, like 400 at Google. So we're talking 2000, 2001 timeframe probably. And what he was put in charge of was to be the architect for the team that developed the Google file system, which doesn't necessarily sound, incredibly interesting or sexy or anything like that, until you realize that it's unique and special in a couple of different ways. One is that it was an infinitely scalable file system, and it's an oversimplification, but do you remember the day when you bought the thumb drive and it said if you want to store a file that's larger than, say, 2 gigabytes, you have to reformat, It's because file systems aren't typically infinitely scalable, right? So it was unique in that way. The second way that it was unique was that if you think about Google back then and how it progressed and became the company that it is today, the file system was one of the foundational components that actually allowed Google to become the company that they were. So it is incredibly important in Google as a foundational aspect. When he left there, are you familiar with the company Nutanix? Nutanix? Oh, okay. You're the second person today. It's just a part of technology, so I feel like everyone has heard of Nutanix. So Nutanix, he and another person were the founders of that company. They revolutionized how we basically built hardware or deployed hardware for virtualized systems. So if you were using VMware or something along those lines, they also had their own. They came up with this thing called hyper-converged infrastructure, right? Kind of marrying the three things that you need in virtualization, memory, compute, and storage, right, into a node and cluster. Made it much easier to scale those environments up and out. And this was after virtualization had become very popular, but really before the cloud had kind of taken over and everything was getting kind of sucked into the cloud. But from a virtualization perspective, the two are very similar. But HCI was is actually an entire area within technology. Now there's many companies that are competing in that space. Nutanix is still around. When he left there, he formed Cohesity. And the thought process that he had when he did that was, how can I take the things that I've done before, hyper-converged infrastructure, revolutionized that, an infinitely scalable file system that I had a part in developing and I understand quite intimately, right? And take those and find another area within technology that I can go ahead and innovate. And so he looked at secondary data. So I had asked you earlier if you knew the companies Cohesity or Veritas. They are basically two of the largest players in this space. And when we say secondary data, we mean backup and recovery, right? So that's this bottom bar, right? Backup and recovery, whether it be your school system, whether it be another government agency, a state or local agency, a federal agency, all of us, we're all mandated to back up all of our data, right? Back up all of our machines, all of our servers, all of our file systems, all of our databases. And before 2015, primarily the reason for doing that was to last through a natural disaster, a hurricane, a tornado, one of those things, right? And so the mandate of the team that runs backup and recovery, which is the infrastructure team, their mandate was to just lock data up, get it somewhere so that it'd be safe, make sure you had multiple copies, make sure the copies were in different places, those types of things, so that if one of your data centers or one of your buildings got run over by an F4 tornado, you'd still have that data somewhere else and you wouldn't have lost it, right? When we developed the company, we wrote another file system. So ostensibly, he did that with all of the lessons learned when he made the Google file system into a new file system. We call that SpanFS. And it's also unique in a couple ways. One, it's also infinitely scalable. But more importantly, which is different than the rest of the industry, it leaves all of the data in its native format, right? And that will become important here in a little while, right? But he also decided to put some things in there that ended up being a very good thing 2 or 3 years later, in 2015, 2016, when security problems and ransomware and destructive attacks and wipers and all those types of things were being deployed against organizations and industries, right? So he wrote things into it such as immutability. Are you familiar with immutability? So immutability basically makes it so that once you write something to it, it cannot be altered, changed, encrypted, deleted, any of those things, right? Another one is worm, or write once, read many, right? And it cannot be, if you do it correctly like we did, even an administrator wouldn't be able to actually delete it. And I'm sure you can see why that would be very important in situations where somebody gets into your system and they want to do malicious things. They want to, say, encrypt everything and then ask you for a ransom. If that data cannot be encrypted, changed, or deleted, right, then you're going to be able to recover from that data. Now, of course, that's a whole different conversation. We're not going to talk about that today. But that is the second bar, right? The second bar is security. We also added other things in there. What we saw in other infrastructures or more legacy technologies was bolt-ons when security became a problem. When people wanted to move to the cloud, it was a bolt-on cloud gateway, right? And that's usually a clear indicator that technology is ripe for innovation. Is you've seen the base technology developed, and then over time, there's bolt-ons to basically keep the capabilities moving forward for that product as customers' needs and capability requirements change, right? So we wanted to simplify that, right? Why is that important? And I know see, I want to walk away from the podium, sorry. The reason why that's important is data is not necessarily secured in other systems, right? The primary data systems, tier 1, tier 0, those storage systems, the mandate there isn't necessarily to protect it from some sort of cyber or natural disaster. It's performance, speed, and capability in those, right? It gets put into secondary data to save it so that it is there when some of these bad things happen. So if you're not familiar, this is Sophos, is the source of this information. Sophos is an organization, you might get emails from them, and they do a really good job of basically boiling down. This is just for destructive cyber attacks. We're not going to read all of them. The couple that I want to point out, though, specifically because you work for a state organization, one is 59%, right? 59% of the respondents in 2024 said that they had to respond to a destructive cyber attack incident. So that's 2 out of 3. Right? So the chances that you're going to get hit is pretty good. 94% said that the attacker went after their secondary data, so their backup data, because if you can't respond or recover, you're basically dead in the water. And the last one is next to that 70%. It says state. Get the exact wording. State and local government reported higher, not 70%, 98% of the data was actually that was found by the adversary was encrypted. All right, we're gonna, because I've already talked about these, we're gonna just kind of move past those. All right, so those are the bottom 2 bars. That was what we were formed as a company to do, right? Was to become the most modern backup recovery, cyber resiliency, cybersecurity product for protecting your data management, okay? Once we got there and we basically realized we were basically best in breed, we turned around and bought one of our largest competitors, that was Veritas. So together, the combined company, these two, Veritas and Cohesity, under the name Cohesity now, were the #1 data protection or AI-powered data protection and cyber resiliency company in the world, right? And it was really, Cohesity buying Veritas was really a David eating Goliath kind of moment. We were the small company, they were the large, had been around for 30 plus years, and this 12-year-old company went ahead and bought them, combined the two together, and we're in the process, actually quite far through the process of combining those technologies and getting basically the best of both worlds. This is where the competitive landscape in secondary data stopped, right, was these 2 bottom bars. right? Because remember, the mandate of who they typically work with is the infrastructure side of the house, not the data side, not the security side. And their mandate is to just lock the data up so that it's there when something tragic happens, okay? We said, this infrastructure also represents an infrastructure that contains all of the important data within an organization. They're mandated to do it. You know, if you're a state, local, or federal government agency, in NIST, it's printed in NIST, it's printed in OMB, it's printed in executive orders. You have to back up your data. So, you now have an infrastructure with all of the important data within an organization. We also do the data classification, so I know where all the sensitive data is. I have a very good understanding of where all the data is. Going back to what I said earlier before you came in, one of the differences to our system amongst all of them within the competitive landscape, we wrote our own file system. And one of the things that we did differently was, instead of going the traditional route that other organizations have and store everything in blob, right? We leave it in its native format. It's encrypted, it's deduplicated, it's compressed, all the things you'd expect, right? But it's in its native format. We also, when it ingests, we index everything. You know, I say this to be somewhat comical, but let's just say I've got 1,000 VMs. I can tell you exactly where all system.dll files are, like this. I can tell you if there's anybody has a file on their computer named password.txt. It's happened, right? And I'm being a little tongue-in-cheek with that, but it's indexed, so it's very easy to find the data that I need, okay? So that's these top 3 bars. We're not gonna really focus too much on mobility and access, but some of the components of those, what if I want to spin machines out to the cloud? What if I want to tier my unused data to cheap deep freeze cloud storage, right? What if I need to move data because I'm doing something and I need some of this data over here? How do I get the mobility? Then the access. I mean, we're probably all practicing DevSecOps to some degree, or some dev something at some point in our organizations. Why aren't we utilizing backup data for dev and test? I can create up zero-cost clones of the data so that I can do dev and test with it, instead of utilizing synthetic data that I have to make up to do my dev and test, right? So those are those 2, just a couple of pieces there. We're gonna talk about insights today, because the other thing in that data is I have a lot of value and information in that data. Right? You might ask yourself, why haven't organizations utilized their secondary data infrastructure in the past to do this? And that goes back to how it's stored. I was talking to the IRS actually 2 or 3 weeks ago, the CTO at the IRS, and he was describing, he does not have us yet, we're in that conversation. He was describing to me that, and this was a common occurrence, that sometimes they need to go get 7 years worth of a particular type of data. Right? And it is stored in that inaccessible format, right? None of this data is going to be in their primary data. That's probably the last 30 to 90 days. They need data 7 years into the past. And so he explains this week or 2 process of just trying to get that data out of archive. And he goes, at some point, we'll think, okay, I think we have enough data. Right? So now I'm going to move that data. Now I'm going to start the cleansing, the normalization process, all the things that I need to do to actually do just to get it into analytics or into BI or into like a machine learning or AI learning, right? So I've just wasted weeks just getting to the data, right? We showed him how we could do that whole thing and say, no, you actually have all of the data. You're not getting to a point where you think, I think I have enough data. I can show you all the data that you asked for. I need this, and I can find it. Then I can also slide the time window back and forth and say, I need it from this period, or I need it from this period, because I've been saving your data for, some companies or organizations, it's in perpetuity, right? I have all their data sitting inside the system, right? One thing that I do want to clarify, though, is I'll continually use the word secondary data, right? And if you're not familiar, primary data, secondary data, this delineation is really clear when we talk about a performance perspective. Primary data has to be on extremely performant hardware because it's running databases. millions of requests per second, those types of things, right? Secondary data doesn't. It's more about capacity. I have a very low cost, lot of storage, right? But from what we're talking about, the content perspective, it's not a clear delineator, right? Because you might think, primarily, we always think 30 to 90 days, depending on the organization, right? But all that data is represented in secondary data too. Up to my last backup. Most organizations are backing up some things every 15 minutes, like databases and such and logs. But then even systems and files and objects, probably within the last 24 hours, I would say, is probably the average. So I have all primary data from a content perspective up to, say, about 24 hours ago is probably the worst, right? Anyone here know this man? Ever heard of him? Craig Martell? Well, great speaker. If you ever get a chance, go see one of his videos on YouTube. Craig Martell, the things that he did before becoming the CDAO for the DoD, or the first CDAO, Chief Data and Artificial Intelligence Officer, was he led the AI at LinkedIn and Lyft, right? So long history in being able to do AI. And if you're not familiar, both of those companies employ a lot of AI in their systems, right? And so he was asked to become the first Chief Data and Artificial Intelligence Officer for the DoD. It was a new position, but they knew, if we're going to be moving into AI, we need this position. And he was like, yeah, absolutely. So one day, day one, he tells this story. He gets asked to come to a meeting, led into a conference room, probably in some secret squirrel place in the Pentagon, and the room is filled with a bunch of flag officers. If you don't know what that means, they're basically all generals, 2 stars, 3 stars, 4 stars. And they say, all right, Craig, you're here, you're gonna AIify us. And he goes, nah, that's not how this works. And so he basically laid out these 3 things. Oops, oh, okay, I'm looking at the wrong screen over here. Data, analytics, AI. And he goes, the way that you get to AI has to start with data. And the overly simplified axioms there are, it has to be a lot of it. It has to be, hopefully very clean, well organized. I need a lot of data. Then eventually we can take that data and we can get to analytics. And then eventually we can get to AI. But you can't skip these steps. Most importantly, you can't not start with good quality, a lot of data. If you do, what you're going to get in the end is not what you're going to expect. He also always says, like, boiling it down overly simplified, all AI is statistics at scale, right? So I'm basically taking a lot of data from the past and I'm putting it into something because I want it to categorize or predict something in the future, right? Is what most of it is. Even if you take a look at ChatGPT, it's really just predicting, We think it's intelligent, but it's not necessarily intelligent. It's complex enough that it seems extremely intelligent. All right. So since we're going into the AI conversation, I also want to make it clear that we're all enamored with generative AI. And yes, we're going to talk about generative AI today. But there's we've been using AI for years, right? And these are actually the components in our product that we're not talking about today, and we call these platform AI, right? That we do that runs off of AI, right? So all the security things, data classification, data entropy, threat intelligence, ransomware detection, behavioral anomaly detection, and then there's some things that are for operational efficiencies like capacity planning and prediction, right? But all of these run on AI. The one we're going to talk about again is the data insights side. Come on in. All right. The other thing is there's lots of different types of AI. Again, we all think, generative AI, which is really a layered mixture of different types of AI. There's machine learning in there, there's deep learning, there's neural networks probably in some of it. It's definitely machine learning, natural language processing. So there's a lot of that in there. But there's many things that fall into that category. It's not just generative AI. And I do apologize, by the way, at one point in time, I would take these out of the deck when I was talking to an AI crowd, assuming like they already know all of this stuff. And I have since learned that I leave them in there. So just bear with me if I'm just telling you things that you already know. We look at AI for us 3 ways, okay? And I would actually say there's 2 and 3. I want to create this distinction between an AI feature and an AI capability. I think that there's confusion when it comes to AI, very similar to the zero trust craze from a couple of years ago, where there is zero trust, I play nice in a zero trust environment, or I provide a zero trust capability that meets one of the requirements. Those are different, same thing. There's an AI feature, and then there's an AI capability. These mostly are AI features, right? They're not providing you the ability to do other AI. So insights is the AI capability, which we're going to spend most of our time talking about here today. And then lastly, another AI capability, which we see to be the future for us. We're actually already doing it, but we want to create specific tool sets to do this, is insights. Basically, how do I use AI to get intelligence, information out, or knowledge out of the data that's already in the system that you put there because you're mandated to do so. Whereas ecosystem is, how do I take that data and provide the tool sets to then do something I want to do, like a machine learning project, data graphing, maybe lineage, provenance, something along those lines. I want to do an analytics project, a BI project. I want to curate a data set and give it to Databricks, all those things. Become the curator of the data. And I won't use the word pipeline because we all know that means something a little different. Okay. So, product we're going to talk about today is Cohesity Gaia. I'll head off any questions that I probably get at the end. Gaia stands for Generative AI Assistant. Okay? I wonder which one came first, the name or the acronym. I'm betting it was the name. Somebody liked Gaia, right? But hey, I cannot confirm nor deny. All right. So we launched Gaia when I came on board, actually, a week after I came on board to Cohesity in February of 2024. So I've only been here about a year and a half, okay? Gaia was actually predominantly the reason I came on board, right? And at that point in time, generative AI's come a little ways, right? But we're gonna talk about generative AI in and of itself being used in a product. And I think that's a bad idea, right? Unless the product, like Adobe Suite, probably good there, because generative AI is a creative tool, not necessarily an accuracy tool. That's one of its problems, right? One else, back then, this has gotten a little bit better, but they're using other technologies we're going to talk about to get over this problem. The large language model itself only has the information in it up to the point it was trained, right? There are ways to circumvent this, but generative AI in and of itself, that is one of its problems. Second problem is hallucinations. We've heard that a million times. It's basically lying to you. Generative AI is a puppy, going back to what I said earlier. It's just predicting, right? And it wants to give you an answer. Best case scenario does this. It tells you that it doesn't know, right? That's best case scenario. More likely, though, it's going to lie to you, right? And we call that hallucinating. We all heard about the lawyers. I think they were in New Jersey. I still like this one. I know it's like a year old now, but the lawyers that basically had ChatGPT write their rebuttal that they submitted to the court, and everything in it was fake, right? It's like a little puppy. It wants to make you happy, right? And it wants to give you what you need. I won't read these out, but if they do give the deck out, some of these are pretty humorous. Because all I was doing was asking ChatGPT, what is Cohesity Gaia? And of course, it wasn't trained up to that point, so it didn't know. And it was coming up with some very creative ideas as to what it thought, Cohesity Gaia might be. All right, and then lastly, and most important one, and through other technologies, we are getting better at this. Like if you go to the Google Search AI, it's using what we're going to talk about next. It can't tell me where it got its information, right? And I still think that there's actually problems with the current one. It just finds, it's basically the same thing as if you just did the Google search and it just picks the top 3 and then gives you a summary of them, right? It's not really giving you a comprehensive answer. So, who here has heard of RAG? No? Okay, good. All right, so this is gonna be fun. So RAG is retrieval augmented generation, right? In the generative AI, you have retrieval AI, generative AI, and RAG, or retrieval augmented generation. So generative AI is creative, right? It makes new content. Retrieval is a a serious subset of that, right? Where I basically give it documents and then I ask questions, and if the information is in that document or documents, it will give me an answer. But it can't create anything new. It won't go outside of that boundary. RAG is the benefit of both, right? How many of your organizations, anyone's organization, utilizing, say, Copilot or ChatGPT, like their own version, like I know a lot of federal agencies are doing that. One of the problems there, too, that generates a whole nother problem set. Because now, as an organization, I have to figure out what data I'm going to give, right? And by definition, because I understand that we're never going to be able to say that no data could ever be extracted from that, I have to understand that any data I give, there is a chance somebody is going to be able to extract that from the generative AI solution. We hear about it, pretty much on a weekly basis. I got all the financials for American Airlines, right? Something along those lines. So we can't give it anything sensitive. RAG allows us to do that in a couple of different ways. Not just RAG on its own, it's actually kind of how we've expanded it. What RAG does is I can take a data set or data, right, out of my backups, and then through embedding algorithms and inserting it into a vectorized database, I can now present this to, by the way, we're only using ChatGPT as an example here, that we're not locked in or anything along those lines. I can present that data via RAG to the large language model. So now what happens is the large language model or generative AI solution is now there for contextual awareness, natural language processing, the ability to have a conversation with it, but it also understands concepts in context, right? So if I ask it about bankruptcies, right? Is there any information about that bankruptcy that happened 2 or 3 years ago? It's going to understand what contextually is in that subject. It's not just going to go search for the word bankruptcy, right? So it's very powerful. And now we've already talked about, like, if I ask it a question it doesn't know the answer to, the best case scenario is it's going to tell me that it doesn't know. In this case, it's going to go to RAG and it's going to go, is there any information in this data set that pertains to this question? And if there is, more importantly, it's going to summarize that information and then provide me right here at the bottom here, these are examples of them. It's going to give me links to where it found the information in my data. Okay, and this is kind of what that looks like as a workflow, right? So the user puts in their prompt, we'll give a really good example here in like 2 minutes. Gaia, then whichever large language model you want to, ChatGPT, Gemini, Claude, Llama, DeepSeek, whatever one you want to use, it utilizes that and the data that's sitting in there, right? And we're about to expose things like biases on information. So I trust this information more than this, or so you can start saying, showing or proving where your authoritative sources of information, even within your own data, come from, right? And it's really good this right now against any text that sits inside of my backups. Right? All right, so by the way, emails, PDFs, Word documents, all those good things. I'm sure at some point in time we're going to start doing multimodal, like visual and graphical and those types of things too. Why is this important? One, it costs less. A couple of years ago, I think it was 2018, 19. Actually, no, it wasn't that long ago because it was after COVID. I was doing a project with Dell. And I went to Dell World, right? We had done a really big project, so we had a big showcase there. And right next to us they were starting to do some of this RAG work as well. But they were touting at that conference that organizations were going to start basically training their own large language models, right? And at the time, I don't think we realized what that was going to take, but that costs a lot of money. So maybe really large organizations, maybe even starting with like a foundational model to begin with or something along those lines, but this costs significantly less. It's also a lot faster than training my own large language model. The other thing too is it's still training my own model doesn't get beyond the date problem. I would have to continually retrain it on the new data that was generated every single day. So it's kind of a gnarly problem, right? So this costs a lot less. Answers are up to date based on the date of the data set. A lot of customers use this to do research from the past. So more accurate, reduced hallucinations, and that's where Gaia fits. It is basically the mothership of the insights side of our AI tree, if you will, right? And we're adding, I'll show you a couple other things after we do some examples, we're adding additional capability to Gaia that are literally coming in from customers saying, hey, I want to be able to do this, or I need to do this, right? And they're incredibly insightful. All right, so as an example, this is one I like because I think the reason why I really like this example was because the gentleman that was telling me the story, or I was working with at the time, just how incredibly blown away and excited he was at the results of this. Okay. Either one of you or anyone do any compliance or have to work with any compliance? Okay, all right. Well, I'll show you. We're going to call the, Gaia, I call it the Swiss Army knife of AI. So I'll also show you how this same use case can transpose itself to hundreds and hundreds of other different activities. All right, so this customer, government agency, they couldn't really tell us too much. What they said was, we got a request from a regulatory agency asking us whether or not any information about a particular event was perhaps communicated with anyone outside of the agency. And I took that to mean inappropriately communicated to anyone outside of the organization. And when they said compliance, I got a strong feeling it was some sort of legal action, and it also had taken place 3 or 4 years ago. But now you could transpose this to FOIA requests. You could do it to PII violations. You could do this with student records and ask questions encompassing every record on that student across their entire career from kindergarten through 12th grade, and get insights and ask questions about that student from that data. And I know that would actually fall into the sensitive data category, and we'll tell you how we get around that as well, or how we fix that problem here in a second. Anyway, I asked them to basically tell me, all right, what does that normally look like? And by the way, is this a normal occurrence? And he said, yeah, actually these come in all the time. This is like, I have a whole department that all they do is this compliance problem, right? It's different questions every single time. It's not necessarily the same thing. And I said, okay, well, what does it take to come to a comprehensive answer for that regulatory body? And they said, well, we only have 30 days to answer the question, right? We have to respond within 30 days. But oftentimes we find that that comprehensive answer that we sent in on day 29 and a half wasn't necessarily comprehensive, because we find a little bit of information afterwards. But what it really amounts to is we have to go back to the IRS story, back into archive to find the relevant data. That is an arduous process. Pull that data out into a primary system. Then more than likely a team, a half dozen of people, are going to be searching through this, because one, they have to come up with all the terms they could possibly think of to search on. Then they have to go through every single, let's just say, in this example, let's make it a little bit clearer. Let's assume that it was a legal action, inappropriately communicated outside of the organization, or the question was, and that would have been emails, OneDrive, documents, attachments, those sorts of things, right? So we have to go find that, move it to somewhere else, do the search terms against it, and then a human's gonna have to read every single one of them and make the determination as to whether or not it was a violation or it wasn't a violation, then take the violations, if there are any, put them in a pile. Somebody's have to write up a summary that comprehensively describes everything that actually happened, and then we have to present that summary and all of the artifacts and evidence with it to the regulatory body. And they said, yeah, month and a half to be certain that it's a comprehensive answer for a team of 6 people. So what we were able to do was, well, we knew where the data would lie, right? We're going on a couple of those assumptions. Could be something else, but we backed up those email boxes for, I think, 100 people, right? And their OneDrives, right? And any attachments and those types of things that might have been, a part of this from that time period, right? Put it into a data set. What did that take? An hour, right? Because it's very easy to find, right? All of that. We know we have them all. And then we just asked the question, is there any evidence in this data that any information about this legal action from March, what would 3 years ago be, 2022, was inappropriately communicated to anyone outside of our organization. And within about a minute or two, it came back and said, actually, yes. And here are the 20 people whose information was violated, and this is who it was sent to, and here are all the emails to prove it, and these are the documents that were sent to them, and da-da-da-da-da-da-da. Right, so within a half a day, one person, we have 90% there. Now a human has to go through and do the reading, make sure that its conclusions were correct, have a little bit more conversation with the generative AI solution and the RAG solution to go like, look again, is there anything that might be misconstrued? We can have whatever conversation we want now with this and refine down that list. Maybe we say, remove everyone from Johnson & Johnson, they're our law firm, they were allowed to see this data, and refine it down. Within a half a day, one person, I've just taken care of six people in a month and a half's worth of work, right? Other ones that organizations are using for? Policy. This was a planning department, state planning department. Policy and regulation interpretation, both internal and external, right? So I put in all the policy, but they didn't stop there. They also took it from adjacent counties, so they could actually do comparison between where regulations and policies were actually different, right? And they basically could provide that for internal, for auditors, for people who work in that department, but you could also put that public facing so that people could ask questions against it to get information for themselves. Like, what is the distance from the side of my property line have to be for my house? Can I paint my porch pink? Right. Anything along those lines. Citizen services and casework. This is kind of like the student example, right? Let's just say it's the Social Security Administration. In fact, I think this was. They have a lot of information, probably way too much information, about somebody who might be filing for SSI, or maybe they've been on disability for 20 years, right? They can put that person into, right? Maybe they want to do a study about disability, so they want to actually put in a bunch of people in, and we will get to see how we make that safe. Cybersecurity. One organization is taking all their incident response reports, which can contain a lot of information. Might have TCP dump or Wireshark traces, information, putting it all into one data set and then asking questions against it, and they're finding IOCs that they missed. They're finding, with these three right here, look like they might actually be the same threat actor. You missed this technique that was used over here. That's the reason why you redetonated 2 weeks later. All that kind of stuff. IT operations, service desk. I take all of our institutional knowledge within the organization when it comes to, let's just say, our product or our IT networks, and I put it into one of these data sets, and now a level 0, level 1, level 2 tech can start asking questions against this and get relevant information on what the problem might be and how to fix it. Right? Not everyone's Jimmy, the guy who's been there for 15 years and knows literally everything and every command and every system. We can't always keep on pulling the superstar down. We need to be able to make it so that these newer people, less experienced people can be just as valuable to the organization. Records and knowledge management, I think that one is pretty self-explanatory. Data-driven policymaking. Let's just say I actually just met with House today, the Committee for Government Reform and Accountability, right? They're very interested in AI and security and cyber resiliency and those types of things. What if they were to take all of the information around a particular subject, also past policy debate, put that into something so they can ask questions like, have we ever tried doing this before? What might be the negative impact of X, Y, or Z, or if we change this policy, how does that affect? So they can actually make better decisions when it comes to policy making. Accelerated, that was Parks and Planning again, accelerated permitting and application review. It also tends to make the outcome more, not predictable is the wrong word, if you have different people, basically approving or rejecting plans or what was it again? Permitting and those types of things. Each one of them is going to interpret things a little bit differently, so it becomes more even across the board. I can't think of the right word. My brain is not working today. Public engagement and transparency, put all the information into a data set, make that public facing, allow the public to actually engage with that and ask questions against, like, why was this done or why was that done? Law enforcement investigations. Working with law enforcement, FBI and law enforcement, oftentimes in an investigation, you've got 8 or 9 investigators actually working on a case. Sometimes they'll go do something for another investigator. They're not even a part of that. But so there's no one in an investigation that really can understand everything that's going on. Take everything about a case, put it into a data set, start having a conversation with that data. I call it basically the big picture of the big picture. Rapid information, streamlined reporting and documentation. That again makes things, I can't think of the word, it's just not going to come to me. And then maintaining privacy integrity. That's just some of them. But we had a customer come to us, loved it. And they said, sometimes I have a data set and I'll make it for a particular reason, but I want to understand what else is in that data set. I want to find the thing that I don't know. Like, how can I do that? You can't do that with just generative AI. You can't say, tell me all the topics that are in this set of data, right? It's going to go, I don't have enough. I actually did it. It says, I don't have enough information to answer the question, right? So we created a topical AI. So when you give it the data set, it will now break down all of the major topics that are discussed inside of that data set. Let's just say it was 100 people's emails, right? It will float up the most prevalent subjects within that data set, and then you can click into them. And if I click into corporate finance analysis, I will then get another word gathering of all the subtopics that it found that fall underneath that particular. We can go 6 layers deep into that. More importantly, on the side here, I have basically questions that you could ask to get the conversation started. So think of this as speed dating with your data, and you get the icebreaker question to open up the conversation, right? I usually get a smile or a laugh at that. I'm just kidding. All right, so what we set out to do were the things, what we saw as problems.
Excuse me, it's just me.
Oh yeah.
Is the last screen the interface of Cohesity?
Yes, that's the dark, format.
Oh, okay. So it's kind of like, it looks like Google Analytics or like Medallia kind of thing, but just more AI focused, or?
Right, and remember, the owner came from, I'm sorry.
Oh, gotcha. Okay. That makes sense.
No, I'm being facetious there. So it does. This is definitely the basic layout, like the menu bar on the top. I would say that pages are a lot more active because this one's just displaying one column of questions and then a word cloud. So I would actually say this is probably the least interesting page, unless you are interested in the topics, right?
Well, with data analytics, I feel like that's really cool. You can really get down to like minute detail of something or someone's path that they went through. I don't know.
Absolutely.
Into those terms.
Yeah, and then you have a slider here. Sorry, topics mentioned: least, low, moderate, most. So you even play in there too. I want to see what the least talked about topics were. I'm looking for that needle in the haystack, right? All right. So these are the problems. Organizations were suffering from massive data, a lot of diverse data sets, sometimes hundreds, if not thousands of different types of data. It was all siloed. Trying to get to data, that's another thing that the data side of the house is saying. Like, when they have to go find the data, they actually have to get through a human or maybe multiple humans, maybe even a security team. Like, oh, no, you can't do that, those types of things. The data is oftentimes dormant. No one wants to go to archive. It's just too hard to work with. They have inefficient search mechanisms. All the data is unprepared and kind of jumbled and mixed together. We solve all of those things in 2 ways. One is the Cohesity Helios, which is the data protection management plane, and Cohesity Gaia solves the 3 on the side. When I came on board, I am the public sector CTO and CISO for Cohesity, and I've worked for other companies where everything that they started building went 100% SaaS, right? And when I got here, we have a SaaS version of our capability set, an on-prem version, a virtual version, and a cloud in my cloud tenant version. So we had everything covered. But Gaia, at the time, was only in the SaaS product. Like I said, this was one of the major reasons why I came on board, and I went to Greg Stanton, the guy who was kind of leading this whole project, and I said, if you want the government to use it, and I know state and local, not that big of a problem. I said, they're not going to want to give their data up, or if they do, they're not really going to give data that's very relevant up, okay? I need what we refer to as a dark side capability. I said, absolutely for the intel community, right? But also very important for law enforcement, and even outside of the government, finance, medical, they don't want to put their data in the cloud. And most of their data is going to be very sensitive data. The DoD, SIPR, top secret networks, we need to have a dark side capability. And what I will say is my last company would never commit to that, right? They just kept on going further and further towards SaaS, thinking that FedRAMP would basically save them from everything. And it's not necessarily even relevant in the DoD without provisional authorization, and it's not relevant in the IC at all, right? And I have to hand it to him. He said, yeah, we'll do that. We'll have it in a year. He said, I can have it by middle of 2025. And he kept his word, right? And through our partnerships with the likes of NVIDIA, who's an investor in our company, actually we're the only secondary data company that they've invested in. They've worked heavily with us to build some of our AI capabilities, but then also Cisco, HPE, and others. We've developed a completely on-premise version of this to include the large language model. All right, so going back to the problems that I hear a lot from those customers and how we get around the sensitive data thing, right? Is one, if you understand how RAG, and I'm sure you'll probably go take a look tonight if you're interested, my data is in the vector database. That is not given to the large language model. That's not how it works. The data is in the vector database. It's not given to that, right? And I won't belabor with how it actually happens. Really, only the answer to my question does the generative AI solution actually see. It doesn't even see the artifacts, right? It's the summarized answer and the location of the artifacts, right? I can also do something called data masking. So imagine this. I have the data in the system. We already do data classification. Let's just say it's children's information, their PII, their sensitive information. I can use data masking before I do anything with the data to obfuscate all of the sensitive data. So I classify, I find that information, and then I use data masking to blackline it, or just delete it, or put in all zeros for the social security number, right? So I'm taking all the sensitive data out of the artifact before it gets vectorized. Now, somebody who would not normally have access or the privilege or the right to see sensitive data, right, can actually work with that data set, right? So now I don't necessarily have to make that decision. The other thing that I control from this is I actually pick what data goes into a data set, and then I can say only you have access, no one else. Or maybe you two people have access to that data. I can also make it so that if you wouldn't normally have access to that data, you can actually do the search through the RAG solution, through Gaia, but you can't actually see the artifact, right? So you actually have to have ownership or rights to read that piece of information, even if it's in the data set, before you can. So then this kind of gives that chain of authorization. You have to go to that person that owns it and say, can I actually see this piece of information? So we can really kind of slice the security in multiple different ways. I think we covered most of these. I want to save some time for the questions, so I'll leave it here if there are any questions. We have 6 minutes. And these are just some of them. I think my list of use cases is way better. But all right, I must have done a.
Just wanted to thank you for the information. I'm here from local government.
Okay.
Colorado.
Okay.
I'm not a really data person, so.
All right.
It was just really helpful to understand, and I guess the biggest problem that we see is those silos, like our data is everywhere. Like,
Oh yeah.
just everywhere. And
Yeah, it's definitely not a mutual exclusive problem. I think every organization, data's everywhere. So I've been talking to chief data officers for over a decade now, and it's been the same problem, for the last 10, 12, 13 years that I've been having those conversations, which is, like, how do I get my arms around the data? And then how do I wrap my mind around it when the data is everywhere, far flung to every corner of my organization? I think one of the more difficult ones, to tell me whether or not you experience this, is the difference between the data hugger or the data owner and a data steward. We don't have enough data stewards, right? They're the owner of that data. They don't want to give up that data, like they're little fiefdoms of data. This circumvents all that, right? They have to put their data here. We're mandated to do it, right? So once it's there, then it should be a much better, risk analysis and governance mechanism that's in place that determines whether or not I get to the data. And now I'm not dealing with multiple personality problems, culture issues, siloing, and stovepiping issues, and it's my data fiefdom issues either, right? So it solves a lot of them. When I go talk to customers and they're talking about AI, a couple things I've noticed is, one, I always ask the question, we have Databricks, we have this, we have that. Okay, those are all great tools. Where's the data come from? That solution is useless if you can't figure out a way to get to data, which is just the first problem. We kind of get it by, absolute default, right? So we solve the data problem. And in the future, that's where we want to move, is being the curator of that data for all of the AI projects. All right. Well, with that, thank you, everybody, for coming. I'll give you guys 4 minutes, 3.5 minutes, back to your day. Thank you for coming, because 4 o'clock in the afternoon, I'm between everyone and either a ride home or a beer. So, thank you for coming.